Okay, YouTube, in this video what we're going to do is continue to raise complex numbers to powers using DeMoivre's theorem. But what I want everybody to see is basically the convenience of doing so with DeMoivre's theorem and writing our number in polar form. So what we see here is that we have this complex number 1 plus I. And we want to raise it to the 8th power. And what I know is if this number were to be written in RCIS theta form, and we were to raise this to the 8th power, it'd be a very easy thing to do because it would just be r to the 8th and then cosine I sine 8 times whatever the argument is. And so our method here is going to be this. If in rectangular form, then convert to polar form first. And so there are a couple of formulas that we want to make sure that we have here. We have our number in a plus bi form. This is this a plus bi form. In other words, we know the values of a and b. We want to be able to find the values of r and theta. And so let's remember this. We would say that a squared plus b squared is equal to r squared, or that r is always the square root of a squared plus b squared. And likewise, let's remember that the tangent of our theta here would be b over a. And so this would allow us to solve for our argument theta if we're going to go into polar form. So my argument, no pun intended, is always going to be to go sketch a picture of the number that you have here. And so in standard form, we would see that we would go 1 to the right and 1 up on our real and imaginary axis respectively. And we could see that this is the situation that we're given right here. So 1 and 1. The only two things we need to find are r and we need to find theta. So you can see that drawing this picture is really to our benefit, because if we didn't remember these two formulas right here, which shame on you if you're not getting those in your head, but if you didn't, you could see that we could really just use Pythagoras, which is what this is, to find our value of r. So let's go ahead and do that here. We would say, r is equal to the square root of 1 squared plus 1 squared, or in other words, it's equal to the square root of 2. So our number here, if we're going to write this in RCIS theta form, is 2 CIS something, and we have to the 8th power. And so I'm going to go ahead and fill this up on my picture here. Now, the other part of this is what theta has to be equal to. And of course, if we knew b and a, or a and b here, we could say then the tangent of theta would be 1 over 1. That is to say, we could solve for the angle if we knew these two side lengths, which we do. And so we're going to say that the tangent of theta from this formula here for our argument, what we're going to say is b, which is our 1, over a, which is 1, or 1. So when we undo this now, and we do a tangent inverse of both sides, really what we get here is the tangent inverse of 1, which we all know that the tangent is 1 if you're talking about a 45-degree reference angle. And so I'm going to work with this in degrees, but we say this is 45 degrees right here. So what we want to do essentially is raise this to the 8th power. What we get is then just 2 to the 8th CIS 8 times 45 degrees. And so pretty easy to simplify. First things first, let's go ahead and do this. We say 2 to the 8th power. We want to get a number here. So 2 to the 8th power, 2 to the power of 8 is 256. And so we get 256, and then we get CIS 8 times 45. Now 8 times 45, this is going to go well over 360 maybe here. It is 360. Oh, okay, well, this is pretty special, because here's the deal. Any angle or argument here that we get that is 360 or bigger, we're just going to rewrite it as a coterminal angle that lands in the same place that's between 0 and 360. So we all know that 360 degrees is the same as 0, but we could say that if we took 360 off of this, we would have a coterminal angle. And that coterminal angle this time is, we're going to call it 0. So here's our number in polar form. This is this number to the 8th power right here. Now our task was to rewrite this into standard form, or rectangular form. So what we're going to do is now convert back to rectangular by saying that really this is 256 cosine of 0 degrees plus I times the sine of 0 degrees. And by distributing this here and evaluating, we get 256 cosine of 0 degrees plus I times the sine, I times 256 times the sine of 0 degrees. And so what we end up with here is really 256 times the cosine of 0 plus I times 256 times the sine of 0, and we just need to evaluate for the cosine and the sine of 0. So with 0 degrees or 0 radians being over here, we'd say that our cosine value is 1 and our sine value is 0. So we'll fill these in, we say 1 and 0. So multiplying this out, what we see that we get here is essentially this. We get 256 plus 0i, or in other words, we get 256. So is that truly what we would get here in polar form, would that be the same thing as what we get in standard form? And so what I want everybody to recognize is that if we were to graph 256 or 256 plus 0i in standard form, we would have gone 256 units to the right, 256 units to the right. We would have said, here's our situation right there. R is 256 and theta is 0. But when we look at this in rectangular, we say, well, we went to the right 256 and up and down none. What I had just said in polar form makes the same exact sense. So in DeMoivre's theorem, we would convert this into polar first and then raise it to the 8th power. But look what we got. We got 256 units out from the origin in a 0-degree direction, which is the same thing that we got once we converted this back into rectangular form. So be able to use DeMoivre's by converting into polar form first and then completing your task, but then converting it back into rectangular form if you need to. Cheers.